Consider this slider crank mechanism with a crank radius of r and the connecting rod has the length L. Now there is an offset between the center of rotation of the crank and the path of the slider, and the value of that offset is delta, right? Now we want to calculate what is the stroke length of this slider. So for that, first we will need to look at the extreme positions of this slider. Now the extreme positions will be when the crank and the connecting rod come in the same line. So the crank is going to rotate like this. So we will have a line where the crank will be something like here, and then the connecting rod will be something like this, right? When they become straight, when the angle between them becomes 180 degrees, that's when we will have the right extreme, right? Now for the left extreme, the crank will be somewhere in this kind of a position, and again the angle between them will be 0 degree this time, not 180 but 0. So the crank will be on this side and the connecting rod will be on this side like this. So now as you can see, I have drawn these extreme positions to the best of my ability, and the blue link is the crank and the red link is the connecting rod, right? And these are exactly equal. Now the right extreme, as you can see, is this point and the left extreme is this point. And this is the length that we want to find, this length, right? This is our stroke length. Let's say that the stroke length is LS. To find the stroke length, we will first draw a line like this through the center of rotation of the crank. And the distance between these two lines, as you can understand, is delta, right? Now we will draw two perpendiculars like this, right? And if we can find the lengths of this line and this line, then we can easily subtract these lengths and find this length LS, right? Now the question is how to find these lengths, this one and this one. So now, if you look at this triangle over here, the hypotenuse of this triangle, that is this line over here, the length of this line is nothing but L plus R, because it is the crank and the connecting rod in a straight line. So the length is L plus R. This length is delta. So we can easily find this third length by the help of Pythagoras theorem. And the value of that third length will be L plus R squared minus this delta squared, and we'll have to take the square root of the entire thing. Now let's say we do this with orange. What about this little length over here? Well, we can do this in a similar manner, right? We can use Pythagoras theorem, and the value of this hypotenuse, if you see, well, this entire length from here to here, this is the connecting rod, right? So that is L, and this is the radius. This much is the radius from here to here. So this length will be nothing but L minus R, right? And once we know the value of the hypotenuse, we can write the length of this guy over here similarly, L minus R whole squared minus delta squared, and we will take the entire square root of that. And if we simply subtract this from this, we will have the value of our LS. So LS is nothing but root over L plus R squared minus delta squared minus L minus R squared minus delta squared, and that is the value of stroke length.